Now if you'll be sure to put the complex numbers in standard form before you start, then complex numbers work just like polynomials. Look at an addition example. Let's add 9 subtract the square root of -8 plus 9 plus the square root of -18. I can rewrite this as 2 minus the square root of 4 times the square root of 2 times the square root of -1 plus 9 plus the square root of 9 times the square root of 2 times the square root of -1. Now notice 8 is the same as 4 times 2. 4 is a perfect square. 2 is what's left. And you have your -1 because we've got the -8. 18 is not a perfect square, but 9 is. 9 times 2 is 18. I've got the -1 because I had -18. I can write this as 2 subtract 2 times the square root of 2i plus 9 plus 3 times the square root of 2i. Now I can combine like terms. I can write the 2 plus 9 together, plus I can write the -2 times the square root of I and the 3 times the square root of 2i. Combining like terms, 2 plus 9 is 11, plus, now -2 times the square root of 2i plus 3 times the square root of 2i is going to be 1 times the square root of 2i. Just notice these parts the same, square root of 2i, square root of 2i, so just added -2 plus 3 is +1. Or I could write this as 11 plus I times the square root of 2. But the key, if it's not already in standard form, you must put it in standard form before doing anything. Let's look at a subtraction problem. Let's subtract 7 minus 3i from 12 plus 2i. So I'm taking 7 minus 3i away from 12 plus 2i. So we have 12 plus 2i subtract 7 minus 3i. Remember polynomials, to subtract one adds the opposite. So it would be of the number of the polynomial being subtracted. So it would be 12 plus 2i plus a -7 plus 3i. The opposite of 7 is -7. The opposite of a -3i is +3i. Now one combines the like terms. 12 plus a -7 plus 2i plus 3i. 12 plus a -7 is 5. 2i plus 3i is 5i. So the answer is 5 plus 5i. Now that answer does have an application. One could place it on the number plane if they wanted to. The real part is 5. The imaginary part is 5. So here on the complex plane is the complex number 5 plus 5i. Now I'm going to give you some exercises to make sure you understand the adding and subtracting of complex numbers. Exercises. Perform the operation. It's going to be hard for you to see all of this, so what I'm going to do is to kind of scroll it over. The first one, 7 subtract 3 times the square root of a -27 plus 8 plus 2 times the square root of -12. So you're adding the two complex numbers. 7 minus 3 times the square root of negative 7, and 8 plus 2 times the square root of negative 12. Now, of course, the first thing you're going to have to do is to change it to standard form using the I notation. The second one, 5 minus 3i, subtract a negative 7 minus 5i. I think you can see all of that one. Once you've copied the problems, stop the tape, work the problems, and then restart the tape to check your answers. Here are the answers. The answer to the first one is 15, subtract 5 times the square root of 3i, or you could have written it as 15 minus 5i times the square root of 3. The answer to the second one is 12 plus 2i. If you disagree with either of these answers, be sure to check with someone. Remember that I've been threatening to miss one on purpose just to see if you're checking it and checking with someone when you disagree. Before we go into multiplication, let's look at the powers of I. Now, by definition, I is the square root of negative 1. Well then, I squared would be the square root of negative 1 times the square root of negative 1, or the square root of negative 1 squared. Now the square root of negative 1 squared is negative 1, because the square just will eliminate the square root. So I squared is negative 1. Now I cubed is going to be I squared times I to the first. Multiply powers having the same base, keep the base I, add the exponents. 2 plus 1 is 3. Well, we know I squared is negative 1. So I cubed is going to be negative 1 times I, or negative I. So I cubed is negative I. I to the fourth is going to be I squared times I squared. Well, I squared is negative 1. So that's going to be negative 1 times negative 1, which is positive 1. So I to the fourth is positive 1.